Good evening. So this is Gayatri, a research scholar, Department of Data Science and Business Systems, School of Computing, SRM Institute of Science and Technology, Katangalattur, Chennai. My paper title is Poa-Dt, a novel method for predicting air quality in major Indian cities. The abstract of my paper is air pollution is a critical environment and public health concern, and it can be exacerbated by urbanization, industrial growth, and increased transportations. So my study is to predict the air quality index using machine learning techniques, especially for integrating the optimization algorithm, that is Pelican Optimization Algorithm, with decision tree method to enhance its accuracy. So the data from the prominent Indian cities is Mumbai, Delhi, Bangalore, Kolkata, and Chennai. We analyzed due to their high pollution level. So the model performance was validated against the traditional machine learning method like KNN, random forest regression, support vector regression. So after optimization, the improved result will be the highest prediction accuracies for Kolkata is 96.68%. That can be followed by Bangalore is 95.66, Chennai is 93.10, Mumbai is 92.48, and Delhi is at 86.61. And the introduction. So pollution. Nowadays, pollution is a very important problem that exists all over the India. So there are around 7 million individuals who has been impacted by variety of problem by the result of air pollutions according to the World Health Organization. So air pollution enhance the possibility of developing the asthma, cardiovascular problem, dermatologist infections like throat infections, lung cancer, respiratory infections, and other some related conditions. So the long-term exposure of air pollutants could raise the probability of early mortality. So during the first stage of industrial era, it was widely recognized that oil and gas, including the gas oil and coal. So these are all the primary energies resources of that air pollution. So according to the World Health Organization, air pollution is accountable for the death of 7 million individuals every year. So over this number, 4.2 million fatalities are caused by the outdoor air pollution, while 3.8 million deaths are attributed to interior air pollution resulting from the combustion of wood and charcoal. So this number highlights the critical need of reliable and accurate techniques for analyzing and forecasting the air quality, especially in the heavily populated metropolitan regions. Okay, so a machine learning based AQI predictions algorithm uses the environmental monitoring and meteorological measures to forecast the air quality index. A hybrid model, so this is our model, so that integrate the various machine learning algorithm to develop and enhance the prediction accuracy. So this ensemble approaches that leverages the support vector mechanisms, KNN, and linear regression, logistic regressions. So this research indicates the method outperforms the traditional machine learning algorithm in terms of the predictions. So next thing is, what are the research gap in this? Uh, in existing model like KNN, random forest, and SVR show the limitations in their accuracy while predicting of AQA, especially in the dynamic and complex environment like major cities where air quality fluctuates due to the various factors and suboptimal model hyperparameters. The traditional machine learning models often rely on fixed or manual hyperparameter. So next one is it is really not applicable for real world applicability. So it is directly applied by the policymakers, environmental agencies to facilitate the timely inventions for air pollution management. So the problem statement here is the accurate prediction of air quality index is critical for understanding and mitigating the health risk associated with the air pollutions, particularly in fast growing urban areas like India. However, the traditional machine learning models like KNN, random forest SVR is failed to deliver the optimal prediction performance due to the dynamic complex nature of air quality data. So in this research aims to address these limitations to introducing the hyper model that combines the Bayesian optimization algorithm with the decision tree. So the optimizing model, hyperparameter and enhancing the AQI prediction accuracy. So this approach is aimed to provide a more reliable forecast that can assist the policymaker into the how to measure this and how to control the air pollution, how to protect the public health. In this research, the primary contribution is to introduce the hybrid model of Bayesian optimization algorithm with the decision tree. So in this model, we can give the accuracy as well as how to improve that. This model is notable, outperforming than the traditional other model. Right. So next, this is the block diagram of Bayesian optimization algorithm with the enhanced decision tree model for improved AQI predictions. So initially the data set can be collected and the data set can be cleaned, and yes, we can pre-process our data. After that, it can give the input to the Bayesian optimization algorithm for feature extraction. So initialization, evaluation, exploration, exploitation, uploading that population and termination. After getting this optimization result, that can be inputted to the decision tree optimization. So by using these evaluation matrices, that is accuracy, mean square error, mean absolute error, uh, like that, we get the result. So this is a pseudocode for Bayesian optimization algorithm with the decision tree. First thing is we can collect the data and pre-process. That is, we can clean. For example, we can clean D cities by handling the missing values and removing the outliers and normalizing the features and then balancing the data. So next one is initializing the Bayesian optimization. So by using this in Bayesians, we can assign that solution vector like DI, LI, BI. DI, LI and BI, that is refers to the maximum depth. LI is refers to the minimum depth, sorry, minimum leaf size. BI is referred to the how many number of bins in that decision tree. Next, we have to evaluate that fitness of that initial populations. First, each Bayesians can be configured by using the decision tree is like DI, LI and BI. Then train the DTI on the data set like these cities. Then predict the values of DI. Then compute the performance matrices MSE by using that generic formula 1 divided by n summation of I equal to 1 to n. Zi minus Zi the inverse the whole square. Mean absolute error, that is 1 by m summation of I equal to 1 to n Zi minus Zi the inverse. Next, random mean square error. Next one is pseudocode, the continuation of this pseudocode. Then evaluate the fitness of Fi using the combination of performance matrices. So here Zi is the actual value, Zi bar is a prediction value, n is the total number of observation. We can update the best solutions to identify which Bayesian is best and which is the best fitness. So we can store that V best. Right. Next, optimizing the loop, repeat until the maximum iteration T is reached. Exploration phase. In this exploration phase, we can update the position of that exploration phase. In this equation 2, that can be represented in my paper. So ensure the updated values are within the valid hyperparameter ranges and evaluated the new fitness Fi for the uploaded Vi. Next, exploitation phase. Exploitation phase using here same thing in the formula that is represented in my paper. So ensure that updated values within the hyperparameter range. Evaluated the new fitness and performance matrices, and if the new fitness is better, accept the new position. That is in equation 5. Next, the continuation updated the best position, updated that it is founding during the exploration or exploitation based on the combined performance matrices, and check the convergence. Which one is best new minus best old? That is less than that or maximum iteration is reached. So we can stop the optimization loop. Next one is final decision model. We can train the final decision tree model, set the hyperparameter of the final decision tree DT op to V best. So we can train the DT option, that is optimization, on the entire entire D cities in the data set. So after getting these optimization algorithm, optimization pseudocode, so next we can discuss about the resultant discussions. We can collect the data from the Kaggle database repository. It is used to implement the approaches that has been provided in the simulation environment. We can take only 2015 to 2020 data set. We can take particularly the 6 largest cities. Why I am taking these 6 largest cities is these are the high populated as well as the high polluted area. So the cities are Mumbai, Delhi, Bangalore, Kolkata and Chennai. So the cities are selected according to the air quality index classification data set, which covers the category from good to severe. So the decision tree classifier is to classify the feature. The tests are carried out by using the Python tool and employing the whatever libraries we want to optimize both the model as well as the classifier. So this is the algorithm, and what are the parameters I used for Pelican optimization algorithm is population size I took as 30, number of iteration is 100, exploration rate is 0.3, exploitation rate is 0.7, decision tree is maximum depth is 10 and minimum leaf size is 5, the number of interval bin is 10. Then Pelican optimization algorithm is used to improve the hyperparameter of the decision tree in order to attain the high level of accuracy in predicting. Here depth of 10 has been selected as an optimal value to be achieved as a compromise between the model's capacity for understanding the complex data and patterns and need to avoid the overfitting, therefore improve the accuracy. By choosing a minimum leaf size of 5, provided that each leaf node included the adequate number of samples, which improved the reliability and generality of the predictions. In addition, use 10 interval bins resulted in an appropriate amount of discretization for continuous features. So this allowed for capture the important fluctuation in the data without introducing the unnecessary complexity. So the combined selection of these parameters significantly contribute to the model, outstanding the result to better accuracy in forecasting the air quality across the analyzed cities. These are all the resultant discussion of how accuracy comparison of balanced and imbalanced data across the cities. So here I am using this mode to convert the imbalanced data into balanced data set. So in this, I am getting that balanced data set have the give more accuracy compared to the imbalanced data set across the cities. So these are all the cities. Instead of using our proposed method, these are all the algorithm used earlier. So Delhi got the KNN by using K nearest neighbor algorithm. Delhi got the 383.68 accuracy. Chennai got the 89.43 accuracy. Mumbai got the 90.03 accuracy. At Bangalore 87.18, for Kolkata 92.24 for using while using the KNN. When we are going to use, when we are use random forest, the Delhi got 84.73, Chennai got 90.45, Mumbai got 90.93, Bangalore got 89.47, Kolkata got 92.11. Support vector regression for Delhi is 84.83, for Chennai is 92.48, Mumbai is 91.03, Bangalore is 90.31, Kolkata is 93.56. For decision tree alone, we are using 87.74 for Delhi, Chennai is 92.79, Mumbai is 91.76, Bangalore is 92.99, Kolkata is 95.1. Now, our enhanced model, the hybrid model of POA with decision tree is getting the more accuracy when compared to the previous traditional model. So that is 86.61 for Delhi and Chennai is 93.10, when Mumbai is 92.48, for Bangalore is 95.66, for Kolkata we are getting 96.68. So our improved model gets the more accuracy. So according to that, we are going to conclude the integration of Pelican optimization algorithm with the decision tree approaches has shown the sustainable improvement in the precision forecasting for the air quality index in key urban areas of India. The proposed hybrid model has attained the prediction accuracy that exceed those conventional machine learning techniques. So these findings highlight the capacity of hybrid model to improve the precision of environmental prediction, which is essential for rapidly and efficiently implementing the strategies to decrease the air pollution in urban regions. So the use of these model has the potential to establish the new benchmarks in the analysis of environmental data. So this would allow the scientific community to attain the more accuracy in predicting outcomes, thereby enhancing the public health and provide the valuable insights for the development of more efficient environment policies for wider populations. So further studies will prioritize improving the quality of data set by including the other cities and also the range of climatic circumstances. So we get the future work by use. You can do these things. We get the more details. So these are all my references. Thank you.